Welcome back. In this video, we're going to talk about 3 rules we've established about angles and triangles, and then talk a little bit about how we can use them when problem solving. So our first rule we've talked about is this idea that straight lines equal 180 degrees. Okay, and this is important to realize because no matter where the straight line is or how many angles it's composed of, it's going to equal 180 degrees. If we were to measure this right now as an angle, it would measure 180 degrees, which means that if it's made out of 2 angles, those 2 angles added together will be equal to 180 degrees. If it's made out of 3 angles, those 3 angles added together will be equal to 180 degrees. It does not matter how many angles are on this straight line. Whenever I add them all together, it will always equal 180 degrees. The second rule that we want to establish is this idea that vertical angles are equal. This means when I have 2 lines that are intersecting here, the angles that are across from each other are called vertical angles, and they're going to be equal. That means that if this angle here is equal to 30 degrees, the one across from it is also going to be equal to 30 degrees. Okay. And our third rule that we want to establish is that triangles have an interior angle sum of 180 degrees. This means if I think about a triangle, the interior angles are the ones that are in the inside. So this angle, and this angle here. And when I add them all together, it has to equal a total of 180 degrees. Okay, so again, we're going to use these 3 ideas here to start doing some problem solving. In our first example here, we are given this diagram and we want to solve for the value of x. Okay, so there are a couple different ways we can approach it, but any way we approach it, we need to realize that here, this bottom line is a straight line, which means that when I add all 3 of these angles together, it has to equal 180. So there are 2 ways we can approach this. One is to think about writing an entire equation that shows that it's all going to be equal to 180. So that means if I would add all 3 angles together, so 30 from the first angle, 6x from the second angle, and 60 from the third angle, it equals 180. From there, we could combine like terms. We'd end up with 6x plus 90 equals 180. We could subtract 90 from both sides. We end up with 6x equals 90. And then we divide by 6, and we end up with x equals 15. Okay. So in this diagram here, we're going to have x equals 15 as our final answer. Alternatively, if you don't want to write this entire equation and solve it, we could also think through, I really only need to know what the value of this angle is before I can solve for x. So I know that this entire thing needs to equal 180. So if I want to figure out what this one is, that means I would take 180 minus 60 and minus 30. So this angle in itself needs to equal 90. Well, then 6 times what would equal 90? We would still end up with x is going to equal 15. In our second example, we have intersecting lines, which really means that we have vertical angles. So our labels are on our vertical angles here, which means that this angle and this angle need to end up measuring the same thing. And that means that we're going to set both of these labels equal to each other. So if this angle has to be equal to this one, that means that 5x has to be equal to x plus 16. Now if we want to solve to figure out what x is, we need to get our variable on one side. So I'm going to subtract x from both sides. That's going to leave me with 4 x's on the left side and 16 on the right because our x's canceled out. And then I know that 4 times 4 would be 16, or I can think about dividing by 4. Either way, x is going to equal 4. Our third example here involves a triangle, and the fact we have established about triangles is that the interior angle sum has to equal 180. That means when I add all 3 angles together, it needs to add up to 180. So we can write our equation as 40 plus 3x plus 5x equals 180. We can combine our like terms of 3x's and 5x's. We'll get 40 plus 8x equals 180. To solve from there, we subtract 40 from both sides. We end up with 8x equals 140, and then we divide by 8, and x is going to equal 17.5. For our fourth and final example here, we are given this large diagram and asked to solve for A, B, C, D, and E. Now this can be intimidating because we do have multiple things that we need to solve for, but if we keep in mind our 3 rules, we'll pretty easily be able to work our way through this one piece at a time. When I first start looking at this, I might think about trying to use the triangle rule, that all the angles have to equal 180 when they're added together, because I notice that there are different triangles in this diagram. Okay, so thinking about this first diagram, or this first triangle in our diagram, that means that when I add A, D, and 60 together, it has to equal 180. Now, unfortunately, I don't know what A or D is at this point, so I could guess multiple things, but I can't guarantee that any of them are true, so I can't start there. I'm going to move to the second triangle. The same thing's going to happen. 75 plus E plus over here angle B have to equal 180, and I can't guarantee what any of those are going to be, so I can't start there either. And the same thing again happens inside of our small triangle. C plus D plus B is going to equal 180, but I can't guarantee it. So unfortunately, we can't start with our rule about triangles. But maybe let's move on to our rule about straight lines. You'll notice down here we have a straight line at the bottom of our triangle, but there's a line that's being intersected or intersecting that straight line. And that makes two different angles here. So when I add these two angles together, they have to equal 180. So that means 160 plus B has to equal 180. That means that angle B now has to be 20 degrees. So we have figured out what B is already. Okay, when I look around, I don't see any other straight lines that's really going to help with, but I do notice over here that I have vertical angles, and I already know that this angle is equal to 80. If we have vertical angles, it means that the vertical angles are equal to each other. That means if this one is 80, that C also has to be 80. Now all of a sudden, I do know here C is 80 and B is 20. I'm put an arrow here. Now all of a sudden I can figure out what D is, because I have 80 plus 20 plus D has to equal 180 since there's a small triangle here. Since 80 plus 20 is 100, that means that D is also going to have to equal 80. Okay, now it comes down to A and E. And now that we've actually solved for that small triangle in the middle, we actually have enough information to solve for our larger triangles and those missing angles there. So in pink, I've highlighted our triangle on the right. We now know that B, this point over here, is equal to 20, and this angle up here is equal to 75. So when I add 75 plus 20 plus E together, it has to equal 180. Well, that means that E is going to have to equal 85. Okay, and we can do the same thing with the other triangle. Okay, I'm going to highlight it in green just so that we can keep it separated. We had already solved for D down here. We said that D was going to be equal to 80. So I'll point at this so we know that it's 80. Now I know that 80 plus 60 plus A has to equal 180 altogether. And so that means that angle A is going to have to be equal to 40 degrees. Hopefully you find this video helpful. Again, we established these three main ideas and then use them to solve problems involving angles and triangles. If you have any questions, feel free to comment below and have fun practicing.